In this lecture, we'll discuss about glacial landforms, their meaning, kinds of glacial landforms. A glacier is a moving mass of ice at speeds averaging between 30 to 40 centimeters and 15 to 18 meters per day. It originates at high altitude due to low temperature and high orographic precipitation. Glaciers are of four types. One is continental glaciers. The second one is ice caps. Then the third one is Piedmont glaciers. And the fourth one is alpine glaciers. The continental glaciers are found in the Antarctica and in Greenland. The biggest continental ice sit in Iceland. For example, has an area of 8,450 square kilometers. And the thickness of its ice is 1,000 meters. The second one, the ice caps form with the valley or at the covers of snow and ice on mountains, from which the valley or mountain glaciers originate. The Piedmont glaciers, the third kind, form a continuous ice sheet at the base of mountains, as in southern Alaska. The fourth kind of glacial landforms are known as alpine glaciers, are found in higher regions of the Himalayas in India and on all such high mountain ranges of the world, while the continental ice masses covering thousands of square kilometers and thousands of meters thick move forward in all directions from their central portions. The valley glaciers or the alpine glaciers move down the mountain slope towards lower regions. There is a great variation in their size. The largest of Indian glaciers occur in the Karakoram Range. For example, the Siachen Glacier, which is around 72 kilometers long, while Gangotri in Uttarakhand, Himalayas, is around 25.5 to 10 kilometers in different parts of the range. So now we'll go to discuss about earthquake. So it occurs when the surplus accumulated stress in rocks in the Earth's interior is relieved through the weak zones over the Earth's surface in form of kinetic energy of wave motions, causing variations at times devastating on the Earth's surface. Such movements may result in uplift or subsidence. For instance, an earthquake in Chile in 1822 caused a 1 meter uplift in coastal areas. Another earthquake in New Zealand in 1885 caused an uplift of up to 3 meters in some areas. while some areas in Japan under an earthquake in 1891 subsided by 6 meters. After the earthquake, earthquakes may cause change in contours, change in river courses, tsunamis, as seismic waves created in sea by an earthquake, as they are called in Japanese, which may cause shoreline changes, spectacular glacial shocks as in Alaska, landslides, soil creeps, mass wasting, etc. A volcano is formed when the molten magma in the Earth's interior escapes through the crust by vents and fissures in the crust accompanied by steam gases such as hydrogen sulfide, sulfur dioxide, hydrogen chloride, carbon dioxide, etc., and pyroclastic material depending on chemical composition and of the lava. A volcano may take various forms such as the central drive when cold lava particles from successive volcano eruptions form a cone around the vent. A conical mountain shape emerges, and this is a central type of volcano. And these type of volcanoes are found in Fujiyama in Japan and Mount Vesuvius in Italy. The magma in such volcanoes is acidic and silicate. The second kind of glacial and that of volcano is the sill type. The less acidic and less silicate magma flows out slowly and quietly and gives rise to a wide-based plateaus-like formation with a gentle slope. Thus a sill-shaped volcano with thin horizontal sheets emerges, and such volcanoes are found in Mauna Loa in Hawaii Island. Then the next one is the fissure type. Sometimes a very thin magma escapes through cracks and fissures in the earth's surface and flows after intervals for a long time, spreading over a vast area, finally producing a layered, undulating flat surface, and were found in the Deccan Traps in peninsular India. And the fourth kind is the calderal lake. After the eruption of magma has ceased, the crater regularly turns into a lake. At a later time, this lake is called a caldera, and such is found in Lonar in Maharashtra and Karnataka, and also at Krakatau in Indonesia. And now we'll discuss about weathering. These forces act over the Earth's surface and basically involve the process of gradation, which in turn is achieved by simultaneous process of degradation and aggradation. The exonetic forces involve two stages. Firstly, the landforms in form of rocks we can break up, rot and disintegrate. This stage comes into play as soon as the newly created landform is exposed to the influence of weather. This stage is called weathering. Then comes a stage of scraping, scratching and grinding on the surface rock. It includes removal or transportation of the withered rock material from one place to another. This stage is called erosion. The act of erosion is performed by a number of natural agents such as running water, groundwater, moving ice, wind, waves, and currents of the sea. These agents use the rooted material as cutting tools. And to carve out and shape the landscape. The distinctive features created by some of these agents are discussed, and in exactly what is physical weathering. The disintegration of rocks by mechanical forces is called physical or mechanical weathering. This type of mechanical force produces fine particles from massive rock by the exertion of stresses sufficient to fracture the rock but does not change its chemical composition. And physical weathering may take place in many ways, like granular disintegration, exfoliation, etc. And now we'll discuss after physical weathering. The second one is chemical weathering. This causes rocks to decay, to decompose instead of disintegrating. The minerals contained in the structure of rocks undergo chemical changes when they get in contact with atmospheric water and air. These chemical changes cause rock particles to break up due to decomposition. Atmospheric water contains oxygen, carbon, sulfur, hydrogen, etc. And the air also contains oxygen, nitrogen, carbon dioxide. High levels of temperature and water content enhance the pace of chemical reactions. And the third one is the biological weathering. This refers to disintegration, break-off and decomposition of rock masses by plants, animals, and activities of man. Plant roots penetrate the cracks in rocks or at the rock base and dislodge large blocks from the cliffs. Roots may also cause breakup of the rock. The burrowing by earthworms, ants, rats, and the like make channels through the rock and contributed to their destruction. Many activities of man, such as mining, quarrying, deforestation, and unscientific agricultural practices like shifting cultivation, etc., add to the weathering of rocks. Biological weathering may be physical or chemical in nature, and the very effects of weathering and erosion tend to level down the irregularities of landforms and create a peneplain. Weathering may cause visibly identifiable changes in the general landscape. A general darkening of rocks, especially in dry climates due to chemical action, creates desert barrenness, and which basically involves changes in the rock skin without change in the volume. The strong wind erosion leaves behind well-accepted rocks in arid landscape. These are called insilvars or ruer. Sometimes a solid layer of chemical residue covers a soft rock through a process known as case hardening. The following action of weathering produces weathering pans or pits, which are also known as ganama or taponi. Sometimes differential weathering of soft strata expose the dome-like hard rock masses called the tors. Tors are a common feature of South Indian landscape. So now we would like to discuss some other important portions such as denudation, denuding factors. So, in that connection, what exactly denudation means? It implies breaking the wearing down of rocks or surface. It includes two different processes: the breaking of rocks material, the carrying away of that material, thereby laying the rock bare for further attack. The denuding factors are wind, water, temperature, glacier, sea, animals, gravity, and man, and etc. Many factors are there behind denudation. And in short, erosion means when the uppermost surface of the earth is worn out by the action of water, wind, storms, then it is simply called soil erosion. And now we'll discuss about what is the meaning of weather. Weather is the name given to the atmospheric conditions, for example, temperature, rainfall, winds, humidity, sunshine, and cloudiness of a particular place on a particular day. And as regarding climate, which means on the other hand is the average condition of weather obtaining in a country or a place for a considerable long period. And finally, we'll discuss about the conditions of rainfall. There should be moisture-laden air. There should be some means by which air is cooled and condensations take place. And these are the very important conditions of rainfall. And in briefly, we would like to discuss that we have left out in the context of volcanoes, and volcanoes are conical hills with a tunnel-shaped hollow from which eruption of hot material or lava takes place. And there are three different named volcanoes. One is active volcanoes from which smoke, lava, etc. always come out, as for example Mount Etna in Sicily. And the second that is named dormant volcanoes, which suddenly become active after having been remained inactive for a long time with a possibility of its eruption in future. And the best very example is the Mount Vesuvius in Sicily. And another kind is the extinct volcanoes which have not shown any activity for thousands of years. For example, Mount Popa in Myanmar or Burma. So we have completed our lecture on lithosphere, the solid landforms and structures of Earth, and in our next upcoming lecture we'll discuss about atmosphere.